Sky Network member webinar. We are, of course, hosting tonight's webinar from the Astronomical Society of the Pacific in San Francisco, California. And we are very excited to welcome our guest speaker, Dr. Nicolle Zellner, with her talk on all about that space science updates. And for our Zoom attendees, again, make sure that you change that chat function to everyone, not just hosts and panelists, so that we can all see what you're writing. And before we introduce Dr. Zellner, we just wanted to give a few brief announcements. Of course, make sure that you report your eclipse events. NASA did have a deadline of the 15th, and so we wanted to make sure that we got all our events in the 15th. So a lot of you came through. I can't even say some of you. Tons of you came through. And I wanted to just say that from April 8th, 2023, because I went back and did all of the numbers from 1 year ago, April 8th, 2023 to April 8th, 2024, Night Sky Network clubs reported 811 eclipse events, reaching over 118,000 people across the United States and its territories. And you guys should be incredibly proud of yourselves, because the impact that you all had on your communities and abroad, just phenomenal. So I am so happy. Those numbers, I almost teared up. Like, again, you guys did a phenomenal job. So, pat yourselves on the back. Congratulations. And thank you. And, again, keep plugging those events. We still have a ways to go till 2045. So make sure that you get all your events on the calendar now. And of course, with that, all of the eclipse fever has died down just a little bit over here at NSN. So office hours are now open again. If you needed to chat with me about anything that's going on with your club, if you wanted to go ahead and maybe you had questions about your account, maybe you had questions about how to get more active, please go ahead and schedule the office hours appointment, or just shoot us an email. You can email us anytime. I'm always here. Viv's always here. Brian's always here, and we will be happy to answer your questions. Viv, did you have anything else? Nope. All right, sounds great. All right, so let's just jump right into it. Again, welcome to the April webinar for Night Sky Network. And for those of you on Zoom, you can use the chat window to interact with each other, and use the Q&A window on the menu on the bottom edge of your Zoom screen for questions. This way, we don't lose your questions throughout the chat. And again, let us know where you're from. If you're having any technical issues, let us know that too, and you can do that in the chat. As always, like I said, Q&A window is for questions. We want to make sure that we can see them. And tonight we welcome Dr. Nicolle Zellner with her talk all about that space science updates. And just a little bit about Dr. Zellner. She is a professor of physics at Albion College, where she teaches introductory, advanced astronomy and physics courses, and has mentored dozens of student research partners. She has also served as a NASA program scientist in the Planetary Science Division at NASA headquarters. Supported by the NSF and NASA, Dr. Zellner's research interests focus on understanding the impact history of the Moon-Earth system and how those impacts affected the conditions for life on Earth. She studies lunar impact glasses to interpret the bombardment history of the Moon and Earth. And a second project focuses on understanding how the chemistry of simple molecules is affected by impacts. As a woman in science, she advocates for inclusive approaches and practices to increase diversity in all of its forms in the sciences. Dr. Zellner has traveled to Antarctica to collect meteorites and to Chile to tour the biggest and best telescopes in the world. She loves teaching and talking about space, and has been a NASA Solar System ambassador for more than 20 years, communicating with more than 2 million people through public talks, media interviews, and written articles. And in 2021, Dr. Zellner received the Carl Sagan Medal for Public Communication, and she is a fellow of the American Association for the Advancement of Science, one of the highest honors in science, the Heisman of Science, if you will. And she has been a Teacher of the Year and Scholar of the Year at Albion College. Please welcome Dr. Zellner.
Wow. Thank you for that wonderful introduction. Please confirm that you can hear me and that you can see my slide.
We can hear you and we can see you.
Fantastic. Good. So I still have problems. I do all of that, right? But I still have problems with Zoom and sharing slides. So here we go. I was inspired by Meghan Trainor with her famous song from several years ago now, All About That Bass. And I have, as Kat mentioned, given dozens, hundreds of talks over the years. And I started thinking about how I can mix things up a little bit. And these past couple of years, especially with the eclipse just a few weeks ago, it really dawned on me how exciting space exploration really truly is. It's just so many neat things are happening, and I wanted to put together a fun public talk that kind of touches on some of them. Now, the title's a little bit misleading because I'm not really going to talk all about that space, but I'm going to highlight several of some of my favorite or some of the most exciting missions in my experience and some of the science that's exciting in my opinion as well. So I'm I'm going to poll you. I have a form with several questions on it that you'll be prompted throughout my talk to go ahead and answer, though you'll be given the form all at once. And at the end of my talk, I'll share some of the responses that you all have contributed. From a young age, I was drawn to science and to space. And I think this cartoon strip here from Blondie, some of you may remember the Sunday Funnies or the Fun Day Sunnies, and Blondie and Bumstead were common visitors to our house on a Sunday morning. And she here is talking with her friends about all of the things in space, or all the things they're interested in, using these really funny apropos space terms. You know, the restaurant got a 5-star rating, and the cake is over the moon, and Milky Way frosting is the best in the universe, right? So my first question for all of you, based on that first survey question, is what's your favorite space topic? You can type it in the chat if you want, but I'd rather that you type it in the form. Again, at the end of the talk, I'll go back to the form and share some of the responses. Well, I hope some of you are from Wisconsin. That is where I grew up. And when I give a talk like this that has spans the country and possibly spans the generations in the audience, I like to just share a little bit of who I am and where I came from. So I grew up in a small town called Winneconne, Wisconsin. It is about 30 miles west of Oshkosh, Wisconsin, right there in the heart of Packer country. Winneconne is famous because in 1967, the state of Wisconsin left it off of the map, and Winneconne seceded from the Union. We nominated the mosquito as the state bird and poison ivy as the state flower. And after enough protesting, the state put Winneconne back on the map. And now every summer we celebrate Secession Days, where we have one of the biggest parades in the state in mid-July. I grew up as a dancer. I was involved in cheerleading and band and choir all through high school. But I was always drawn to the stars because I grew up out in the country where we had beautiful night sky views. And at the time, and I don't even understand the conditions or really remember the conditions, but we saw aurora fairly often. I mean, enough for it to stick in my mind as a memory. And this prompted me then to go to the University of Wisconsin, where I received an undergraduate degree in physics and astronomy. And then I actually took a gap between undergrad and grad school, and I worked on a space mission called STS-67, the Astro 2 payload. And Wisconsin sent up one of the ultraviolet telescopes in that payload, and I was hooked. I realized that I wanted to do astronomy for my career. So I went to Rensselaer Polytechnic Institute in upstate New York. I saw somebody from New Paltz posted in the chat. My aunt and uncle live in Kingston, and my uncle's always trying to get me to go teach at New Paltz. So I keep telling him, Uncle Jimmy, I just can't ask for a job. I have to wait for them to open, but he doesn't quite get that. So I went to Rensselaer, earned my PhD in astrobiology and physics, and I'll talk a little bit about my research at the end of the talk. After a postdoc position, I ended up at Albion College in South Central Michigan, about 40 miles south of East Lansing, where Michigan State is, and about 40 miles west of Ann Arbor, right along I-94. And maybe there's somebody from Albion in the audience. She texted me when she saw my name as the speaker and said she was going to join in. So hopefully Sally's out there. Hi, Sally. So that's me. Where are you from? That's the second question in the form. So go ahead and answer that. I'm sure lots of people are from the United States, but I did enter Canada and Mexico just in case. And of course, if you're tuning in from somewhere else, feel free to write that on the other line. Okay, so the reason I put this talk together was because I had an invitation from the Albion Area Lifelong Learners, which is a group of former faculty and other senior members of the Albion community who wanted to know all about the JWST, or the James Webb Space Telescope. And I reminded them, I'm not an astronomer, I'm a planetary scientist, so I don't really feel comfortable giving a full talk about JWST, but I realized that I could actually touch on it I could touch on it as a topic in my All About That Space talk. So here's the slide on JWST, and I have a clear memory of being a college student, and JWST was proposed and was going to launch, in the next 10 years or something like that. Well, many, many years later, we had a beautiful, successful launch in December of 2021 on Christmas Day, and JWST unfolded its 8-meter mirror out in space, and it did it completely automatically, and it was a wonder to behold. I'll admit I had my doubts, but it did it, and this telescope is working really, really well. I've got some beautiful images to show you in a minute. The James Webb Space Telescope is located at the L2 Lagrange point, which is about 1 million miles from Earth. This is a point in space where gravity is well balanced, such that the telescope can stay out there and doesn't really need a lot of boosters or a lot of maneuvering to stay stable. This telescope observes in the infrared wavelength range, so that's long wavelengths, longer than the red color. In fact, we emit in the infrared. If you just hover your hand over a body part, you'll feel heat coming off of your body. We're actually emitting in the infrared, so that's kind of a heat wavelength, if you will. So this this graphic here at the bottom shows this very narrow range that's visible, and then this much, much longer range where we see that infrared spectrum that Webb is collecting information on. This telescope is actually observing cool portions of our universe, lots of dusty regions, objects that are pretty far away, things that we cannot see with our naked eye, things that the Hubble Space Telescope can't really see either. So it's a really nice complement to the HST. Big talking point was that JWST is going to be the replacement for Hubble. And yeah, sort of, but they're entirely different wavelength ranges and entirely different epochs of technology. So I'm going to do a comparison for you right here. On the left-hand side of your screen is the Hubble Deep Field. That was roughly a patch of space the size of your fingernail. So I want everyone to hold out your hand with your thumb up, much like Fonzie used to do in the Happy Days eras. And I want you to look at the amount of space that your thumb covers, right? The amount of space on the sky that your thumb covers. That is the amount of space that the Hubble Space Telescope looked at for 10 days at collecting photons to create this image on the left. Almost every single thing that you see in that image is a galaxy, and there are roughly 3,000 galaxies in that picture. So 3,000 galaxies covering space the size of your thumbnail projected out. So the squared off region there is what James Webb looked at. And that's the image I'm showing you here on the right. That's the Webb image. with 0.8 days of exposure. So right away, you can see that the colors are different. You can see that there are some things that aren't appearing in the Webb image that appear in the Hubble and vice versa. But what I hope you can see is how clear the image is with a fraction of the observing time and the fraction of the collecting, a fraction of the time to collect those photons. One of my favorite nebula in the night sky is the Ring Nebula, which is on our constellation of Lyra the Harp. The Ring Nebula is a planetary nebula with a white dwarf left behind. This is eventually what our sun may turn out to be. All low-mass stars end up as white dwarfs with a planetary nebula surrounding them. On the left-hand side again is the Hubble Space Telescope image of the Ring Nebula. On the right-hand side is the JWST image. So you can see again the structure, the fine detail that the infrared telescope that James Webb JWST is creating, that image and the data that it's collecting versus the image on the left-hand side, also beautiful, but two different kinds of images that give us different kinds of information. In particular, in the Webb image, you can see dense globules that are rich in hydrogen and very hot gas in that inner region, which we just don't see in that Hubble image. The Carina Nebula as well, a star, a region in the southern hemisphere sky. On the left-hand side is our Hubble image. On the right-hand side is our Webb image. Again, much more structure in the dust lanes and much more detail even in the background stars behind the nebula. So James Webb with that 8-meter mirror is really doing a lot of work collecting those photons and creating these beautiful images and allowing us to learn much, much more about our universe. One of the hot new topics in astronomy, of course, is exoplanets and exoplanet science. A lot of astronomers were wondering whether or not JWST would be capable of detecting atmospheres around planets. And of course, if we find the right combination of those molecules in the atmospheres, would that be indicative of some sort of extraterrestrial life form? So one of the first tests that James Webb was subjected to was to gather information on the atmosphere of an exoplanet. So this is exoplanet K2-18b. So it's a Kepler planet that was discovered. And in the spectrum here again, and that's an infrared wavelength along the x-axis, and it's the amount of light emitted or intensity on the y-axis. We're seeing a signature for methane, we're seeing signatures for carbon dioxide, and we're seeing some signatures for even water signatures. I don't know if it's in this atmosphere, but we've definitely observed water in the atmospheres of some of the other exoplanets. And this is really exciting, right? As I tell my students, when I was in college, there was one exoplanet. And now, as of March, the last time I updated this slide, over 5,500 exoplanets confirmed, with almost 1,000 of them in a multi-planet system around another star in our galaxy. So Kepler has shown us that probably every star in our galaxy has a planet. You know, if there's 200 billion stars in a galaxy and 100 billion galaxies in the universe, that's a lot of planets to explore. We won't get to all of them, but I think James Webb and some of these follow-up telescopes will help us learn more about planet formation and the possibility of life elsewhere. One of my favorite visuals for all of the different kinds of planets out there are the Kepler orreries. The one that Kat is going to be sending out to you in the chat is the one from 2013 or 2010. There are follow-ups, but of course it's kind of hard to model 5,500 planets with almost 1,000 in a multi-planet system. But if you're looking at that orrery, you will see that there are lots of different kinds of planets, some very close to their stars, some very far away from their stars, some very big, some very small, orbiting at different velocities, and a huge wide variety. The chart here on the right-hand side is a graph that was created from the exoplanet.eu database as of 2022. Along the x-axis is the orbital period in days, so how many times it takes the planet to go around the parent star. And on the y-axis is the planetary mass in Jupiter masses. So Earth is squared off on the right-hand side, out there by itself alone, where we see lots of small rocky planets close to their parent stars. We see lots of giant hot Jupiters very close to their planet stars. We see other gassy planets. We see Neptune and mini Earths as well. But so far, at least as of 2022, it looks like Earth is still a rare thing. A Earth-sized planet with an Earth-sized mass and an Earth-like habitable zone. It's telling. However, we have other ideas out there for what a habitable planet would look like. If you are a small rocky planet orbiting around a high mass, cool red star, for example, you are going to have a very long time to create life because those kinds of small, cool stars live very long lives. The life will look different, probably, but there's definitely chance that there could be life out there as we don't know it, living on planets that we don't know yet and don't know how to characterize yet. So it's very exciting to think about the future of space exploration and this field of astrobiology. One of the most high priority space missions, as determined by the astrophysics community in the Astro 2020 Decadal, is Habitable Worlds Observatory, or HabWorlds. And this observatory is one of the highest priority missions that NASA will start to design and develop and eventually launch in the 2030s. It will be a telescope that can observe objects in the infrared, optical, and ultraviolet wavelength ranges, so a wide spectrum of wavelengths. And it will be the first telescope that's designed specifically to search for life on exoplanets, including Earth-like planets that are emitting about 1/10 billionth the light of the star that they're orbiting around. And the way that they're going to do that is by launching the telescope with a star shade. And so what that star shade is going to do is block out the light of the parent star and allowing those planets that are orbiting very closely to the star to be detected, much like a total solar eclipse blocks the disk of our sun and allowed astronomers in the early part of the 20th century to identify the location of Mercury and thus prove Einstein's theory of relativity. So by blocking out that pesky bright light from the star, HabWorlds will be able to identify very small Earth-like rocky planets that could potentially have life on them. A little bit closer to home, a very exciting mission that is ongoing on our neighboring planet Mars is the Mars 2020 mission, where the little rover named Perseverance is driving around a river delta in the Jezero crater. Jezero, it was identified as the target location for the Mars rover because it looks like it was the repository of liquid in the past. And we know that where there is water, or follow the water, that was a mantra that Dan Golden, one of the NASA administrators from years past, helped promote this idea that if we could find water, we could find life. So we explored a lot of planets and moons where we believe that there is life, or we are exploring those planets and moons where we believe that there's life. So Mars 2020 is a really exciting mission because it's actually collecting and caching samples all around Jezero crater. There's maybe 20 or so sample vials that the Mars rover is actually filling with rocks and other kinds of Mars regolith. And those samples are going to be cached on the surface of Mars until we figure out a way to actually scoop them up and bring them back to Earth, where they will be analyzed in Earth-based laboratories. So you may have heard very recently that NASA has paused its development of the Mars sample return mission and has actually put out a request for ideas in the hopes that there will be some commercial enterprises that will take up the challenge and help us figure out how we can actually collect these samples, launch them off of Mars, and put them into an orbit where they will enter Earth's atmosphere, probably over the Utah desert, much like OSIRIS-REx in late 2023, where they can then be collected and brought to labs all over the world for investigations. Another area of excitement is the exploration of Jupiter's icy moon, Europa. The image on the orange image that you see there is the Voyager image of Europa when it flew past the Jovian system in the 1980s. And one of the most striking observations of Europa was that it had a surface that didn't have a lot of craters on it. And when you're a planetary scientist, you know that if you're looking at a surface without a lot of craters, that there is geological activity of some sort. Craters are being erased, craters are being eroded, craters are somehow not being preserved on the surface. And so a few more with a little bit more data, we realized that there is a briny ocean beneath this icy crust of Europa. When the Galileo spacecraft was out there in the 1990s, we observed these ridges and rifts and cracks in the ice of Europa. And you can see that they are not permanent ice cracks in Europa. They actually move around, they melt, they freeze over, they remelt again. And in those places where the crust actually opens up, there seems to be some sort of seeping up of or melting or seeping up of some sorts of liquid. We've seen icebergs moving through these channels on Europa as well. So this got people very, very excited that there might be an ocean beneath this icy crust, and in that ocean, because it's warm on the inside due to the gravitational pull of Jupiter, kind of creating tidal heating and frictional heating on Europa, that there could be life on this moon. So in various different names and different ideas were proposed over the years, but we finally settled on a mission called Europa Clipper, and Europa Clipper will be launched in October of this year, and its mission will be to go out to Europa and help us understand whether or not the ingredients for life as we know it exist on that moon. There are other missions out to the Jovian system as well currently underway. We've got the Jupiter Icy Moon Explorer, or JUICE, which was launched by the European Space Agency, and Juno is out there now as well. So hopefully all of the spacecraft will survive long enough that they can actually work in tandem together and bring a really rich set of data back to, or send a really rich set of data back to scientists and others on Earth. Titan is also another really, really exciting object in our solar system that may have the ingredients for life as we know it. Again, the orange image that you see on the screen is the image of Titan taken by the Voyager spacecraft in 1980. Titan is the largest moon of Saturn. And we observed that it had a methane, nitrogen rich atmosphere. It was really hard to see through that very thick atmosphere of Titan. Earth-based telescopes tried to do that, made some progress, identified some light and dark regions, but we really didn't know what those light and dark regions were until Cassini got out there in the 2000s. So Cassini and Huygens worked together to understand what Titan's surface looks like. The Huygens probe in particular flew through that thick atmosphere of Titan and took these beautiful images of the Titan surface where it doesn't have a hydrological cycle such that water evaporates and rains back down, but rather it has a methanological cycle. So liquid methane is evaporating up off the surface of Titan and then raining back down onto the surface of Titan. Titan has liquid methane lakes and rivers. There are islands on Titan as well. The temperature is very, very cold on the surface of Titan, but people are really interested in this object because of its really unique chemistry and how that chemistry might give us a clue for formation conditions of life. So in the next several years, 2028, the Dragonfly mission will be launched here from Earth. The principal investigator on that is Elizabeth Turtle from the Johns Hopkins Applied Physics Lab. I've known Zibby pretty much my whole career, and it's just really exciting that she's the PI of this mission that's going to send this rotocopter out to Titan. And it's going to fly along the surface of Titan and sniff out organics. And where it finds interesting organics, it will do a deeper investigation and send that information then back to us on Earth. Arrival in 2034. So it takes a long time to get out to these deep space objects, but the science return will be very, very exciting. And we'll answer a lot of our questions about the possibility of life on other objects in our solar system. So my next question for you is, what moon or planet are you betting on will have life? So in the form, please share with us whether it's Mars, Europa, or Titan. And I think I have an other in there as well. So if you think it's another object in our solar system, feel free to answer that as well. And yes, I'm going to restrict you to our solar system, okay? Not everywhere in the universe, just our solar system. And if there isn't another exciting mission out there, of course there is. The Psyche mission launched in October of 2023. So last fall, when I was teaching my first year seminar on space exploration, we gathered around the NASA TV and we watched this beautiful rocket launch of the Psyche mission headed out to the Psyche asteroid. Psyche is a really, really interesting asteroid because we believe it to be only composed of iron and nickel. And one of the big questions is this a core of a planet that no longer exists? Or is it just a hunk of metal out there in space, potentially left over from the primordial planetary nebula from which the rest of the planets formed? We're going to answer that question because there's a magnetometer on board. And when that magnetometer goes into orbit around Psyche, it's going to be able to measure magnetic field. We know magnetic fields are formed around planets that are rotating with liquid metal cores. Earth has a magnetic field, of course. It protects us from the harsh ultraviolet gamma rays and other cosmic rays from our sun and from the galaxy. It gives us the weak spots, of course, in our magnetic field are where those that solar radiation can come in, interact with our atmosphere, and give us our beautiful northern and southern lights. Mars has a remnant magnetic field. Venus has a remnant magnetic field. If this Psyche asteroid has a magnetic field around it, it's probably the core of a planet that no longer exists. And if it doesn't, then it's a piece of primordial piece of the formation of our solar system. So in either case, it's going to be a very exciting contribution to our understanding of solar system formation. If mining companies find it justified and cost effective, there are ideas to mine our planetary bodies for resources. And the iron and nickel on Psyche is worth over 100,000 quadrillion dollars. I can't even say it, it's so much money. But of course the technology and the cost benefit of trying to do this kind of mining is not quite there, though people are thinking about it. And our moon in particular is another place where people are thinking about how to mine the resources on the moon. Again, this launched in October of 23. I think it's going to be about 6 years before Psyche gets out there to the asteroid. I may be wrong on that, and if I am, please correct me in the chat. But once it gets there, it's going to be very exciting, again, to see what kind of results are returned. We are not bringing Psyche back to Earth, but We do have a piece of Bennu, which was returned to Earth also in October. That was another day that my students and I gathered around the TV to watch the re-entry of the space capsule and the landing in the Utah desert. Bennu is a primitive asteroid. It's a kind of square in shape. You can see that in the upper right-hand picture. It has lots and lots and lots of boulders on it and other rock. In fact, Bennu had a swarm. It appeared to be a swarm of material around it, something we had never seen before around an asteroid. So the Japanese have pioneered the return of asteroid samples. They've done it a few times. This is the first one that NASA has done. In the lower right-hand picture, you can see some of our colleagues in a bunny suit in the clean room, disassembling that capsule and extracting the material from the inside. So the material is being investigated. One of the big questions is, what did the amino acids on Bennu look like? Do we see a dominance of left-handed amino acids over right-handed amino acids? Left-handed amino acids are used for life as we know it. That's the kind of amino acids we have in our bodies. If so, how does that compare to the amino acids that scientists have studied in other kinds of meteorites, in particular, that have been collected in various places around the planet? There are other sorts of investigations going on with the samples as well, including cosmic ray exposure ages, solar wind implantation, and also understanding just the cratering rate on that body, which can tell us then about the interior geology or the interior structure of Bennu. I'm sorry, of Bennu. So closer to my heart is the return to the moon for the first time in over 50 years. I'm a lunar sample scientist. I was introduced to the study of lunar samples when I was a graduate student at Rensselaer Polytechnic Institute, and it's been really exciting for me to be in this era where we may actually go back to the moon. I studied Apollo samples that were collected before I was born, and I'd really love to get my hands on some Artemis samples in order to continue my investigations. So in November of 23, is that right? 23 or was it 22? I'm mistaken now. Must have been 22. In November of 22, Artemis 1 was launched. This was an uncrewed test of the launch from Earth and then looping around the moon. In the spring of 23, the Artemis 2 crew was announced. These are these wonderful astronauts that you see on the right-hand side, including Christina Koch, who was born in Grand Rapids, Michigan. So that's kind of a nice tie-in here for the Michigan group. And Victor Glover, who will be the first African-American to actually orbit around the moon. Christina Koch will be the first woman to orbit around the moon. And these four daring individuals working together as a team will do the test run for human landing on the moon, which is currently scheduled for 2026. And that mission, Artemis 3, will have the first woman and the first person of color who will actually set foot on the moon and return samples to Earth. So NASA put out a call for an Artemis 3 geology team. Several of my colleagues were on the winning proposal, and they are working with NASA to investigate the landing site and the geology of the landing site, and helping to advise the astronauts on which samples to collect to maximize the science return. And what's really interesting about the Artemis 3 landing site is that it's on the far side of the moon. So those of you who are interested in lunar science and know the Apollo story, you probably know that all of the Apollo missions were in a very narrow region in the equatorial band around the moon. And that was because we wanted the astronauts to be in constant communication with the Earth, with Houston, with mission control, and we wanted them to be able to use the sun both to help regulate their body temperatures, regulate their spacesuit temperatures, but also to help them see in the collection of samples. Artemis 3 will be on the far side of the moon in very near some permanently shadowed regions of the moon that never receive sunlight, and mostly those PSRs are in the permanently shadowed regions of craters, and it's in those PSRs that we think we'll find really interesting volatiles material, including water, and it's really important if we're going to have a sustained presence on the moon and a sustained human settlement on the moon, that we have a supply of water. Water will provide not only water, right, but we can actually break it up into oxygen to breathe and hydrogen for rocket fuel. So this Artemis 2 crew will be doing that test run of the human occupancy inside of the capsule in preparation for Artemis 3. The next link to the video I wanted to share with you is the Earth to the Moon video. Maybe some of you are watching it already. It's about 3 minutes long. I won't spend too much of a pause on that, but this beautiful video was put together using really high quality spacecraft data from recent missions to just help you appreciate that beautiful barren landscape and how wonderful yet dangerous it will be for the next astronauts who will be exploring it. In the meantime, while we're waiting for humans to return to the moon, we have a very prominent and prevalent commercial industry, a commercial space exploration industry. NASA has provided funding opportunities for commercial space companies to bid on opportunities to both launch vehicles to the moon and also to land spacecraft and rovers on the moon. There were some news announcements in the past couple of months for the Peregrine Peregrines made by the Astrobotics company, as well as Intuitive Machines, which crash landed on the moon in February of 24. So even though they crash landed on the moon, they were still the first US landing in over 50 years on the moon. And everything that we learn from these launches and these landings will only forward feed into lessons learned and improvements for the next go round. So the commercial space businesses are really helping NASA and helping scientists as well develop and gain more information about space exploration. There's also a plan to put a small orbiting space station around the moon called Gateway. Gateway will hold anywhere from 2 to 4 crew members and allow them to live and work while they make sorties to the lunar surface and collect samples. The idea is that the Gateway will be their home away from home. They will collect the samples, bring them to Gateway, and then launch them from Gateway on a return trajectory to the Earth, where they will be collected by scientists and studied in our labs. So these are things that are pretty exciting for a lunar scientist like myself to think about NASA's commitment to return to the moon and the things that we're going to learn. So as I said, I am a lunar scientist and I study lunar impact glasses. These are microscopic pieces of glass that are formed during the heat and temperature of an impact event. So just like we get glass by melting sand on Earth, we get these impact glasses when the regolith on the moon is melted in a high temperature event. And these impact glasses contain a memory of where they were formed, so their geochemistry, and also when they were formed, so their geochronology. And we can do some really good high resolution and detailed studies of their chemistry and their ages to find out and answer questions about the bombardment history of the moon, which is used as the touchstone and the proxy for the bombardment history of the inner solar system. Our Earth is 70% water, it has plate tectonics, it has an atmosphere, and it doesn't do a good job of preserving impacts. There's just a few very large old impacts on the Earth. The moon, on the other hand, with no water, no atmosphere, and no plate tectonics, preserves 4.5 billion years of impact history on its surface. So by collecting these impact glasses, we can begin to fill in that understanding of the bombardment history of our solar system. And in particular, we're interested in answering questions about what was going on with bombardment in the solar system during its first 700 million or first billion years of solar system history, when the solar system is settling into the current configuration that we have now. We know that there were very, very large impacts. We know that there were moon-forming impacts, right? Our moon was likely formed when a Mars-sized object collided with the Earth. What does and we want to answer questions about what that bombardment does to habitable conditions on Earth or Mars, for example, or the delivery of biomolecules to Earth or Mars, for example. So these are questions that impact glasses, in addition to other kinds of impact samples, can answer. The fact that the Artemis samples will be from an entirely different geological region of the moon is really exciting for me, because those Artemis samples will most definitely contain impact glasses. And then to understand what those impact glasses tell us compared to what the Apollo impact glasses are telling us would be really exciting for me to study. And so finally, I want to just bring it all the way home, back to my home school at Albion College, where I've been for almost 20 years. Albion College has an Elvin Clark telescope. For you astronomers in the group, you know that Elvin Clark and his sons, Elvin Clark and Sons, was the premier telescope maker in the United States in the 1800s, late 1800s. They wanted to compete with the best French and European and other European telescope makers at the time. Albion College in the 1880s decided to raise $10,000 to build an observatory with the best telescope equipment in the country available at the time, with the motivation that every student would take an astronomy class, and that was a requirement until the 1930s. The Elvin Clark telescope is an 8¼ inch refracting telescope. It is celebrating 140 years of existence this year in 2024. Based on some work, we believe that our Elvin Clark telescope is the only telescope of its kind still in its original home. So that makes it a really important piece of astronomical history in the United States. Not only do we have the Elvin Clark telescope, which is the central image here, but we also have a transit telescope, which is on the right-hand side. And that transit telescope, again, was built in the 1880s by Faust and Company. And what that transit telescope would do is actually mark time along the railway from Detroit to Chicago, and mark time as stars were passing overhead. So over on the left-hand side, you can see our building, which is it's where the Honors College is housed right now, and this is on our quad in Albion College. The dome, of course, very classic shape, has a pier that sunk 30 feet into bedrock. And then on the right-hand side of that picture, you can see a slit in the roof. That was the retracting slit where the transit telescope, which lives in that room right there, that's the slit that the transit telescope would observe through. So it would only mark the passage of time of stars moving overhead. And in that transit telescope, we have something called a Filar Micrometer, which actually measures celestial distances between two very close stars, and allowed astronomers, including Albion College students in the 1800s and 1900s, to measure distances. And those distances were measured with spider webs. It turns out that spider web is one of the strongest materials ever, anywhere from 1/5000th of an inch thick to 1/500,000th of an inch thick. And we still have 11 of the original spider webs, spider silks in that Filar micrometer. And so how that would work is I've got my two little cartoon stars here. And as the stars are passing overhead, you could actually time how long it would take the stars to move through those crosshairs, and then with a very simple geometry, you'd be able to measure the actual celestial distance between the binary stars. So I never thought I'd be a historian of astronomy, but when you have such a wonderful story and such beautiful pieces of equipment on a campus, you just can't help but get excited about it and want to learn the history. So that's what I did. All right, so that wraps up more or less my my talk for today. Can't not talk about the April 8th eclipse. And I know some of you are already checking in about where you were and what your plans were on April 8th. We actually had a wonderful viewing session on campus. I recruited several students and the event basically ran itself. I stockpiled eclipse glasses after I saw what happened in 2017. So we had thousands of eclipse glasses to give away to our community and to our campus. Albion was at about 97% totality, but 97% totality is like 97% of the way to Disney World. So I went to Carmel, Indiana, where I saw totality with one of my best friends, and that was exquisite. So where were you on April 8th? Please answer that in the chat because I couldn't think of enough options for a form. And I also would like to remind you, if you don't know already, about Astronomers Without Borders. Astronomers Without Borders is a nonprofit organization that collects the used eclipse glasses for distribution to underserved countries when eclipses are occurring there. So Albion College is one of the collection nodes. We have thousands of glasses that have been coming into us since April 8th, and some really dedicated students that are working to vet them and make sure that they're good enough to store until Astronomers Without Borders needs them for a future eclipse. So if you don't know who they are, Google them. If you want to be a collection node, they really need people to help with this collection and vetting process. Then we'll store the glasses until they're needed. So you should probably think about what kind of storage space you have as well. And of course, we'll just count down to August 12th, 2045. Where will you be? Go ahead and put that in the chat as well. And if you can't wait until 2045 and you think you might go to Iceland in 2026, that's okay. But these solar eclipses are addicting. They're spectacular when the weather cooperates. And it was a really, really fantastic experience. I went to the annular in October as well in Midland, Texas. It was beautiful as well in a different way. I really just love the way the country, my campus community and the country came together for this celestial event. And with that, I wanted to tell you about one other program that's near and dear to my heart. This is NASA's Bridge program. Bridge is a funding opportunity for under-resourced institutions like community college, tribal colleges, primarily undergraduate institutions, to partner with NASA in order to create meaningful research experiences for students and to help make STEM careers more accessible to more people in our country. It was co-created with hundreds of people from around the country. You can see the map over here on the right-hand side where we had participants who helped create the program, and they wrote a report for people at NASA to actually about what they want this program to be. We've had several proposal selections already. As of January, we awarded more than $2 million in NASA funding to many first-time principal investigators from a wide variety of under-resourced institutions in our country. So if you are a science educator, a professor at one of these smaller schools, and you're interested in doing work at NASA, please contact me. We have a matchmaking program where we have people at NASA who are willing and interested in doing research projects. And this is a long-lived program, so it is available. We will have some announcements for funding opportunities in ROSAS 24 in the NASA solicitation cycle. And the QR code at the top, let me move that down. The QR code at the top will give you some information about the Bridge program. And that is my last slide. Thank you so much for your attention. I see so many chats and questions, and this has just really been delightful. This has been great. Thank you so much, and I'm really happy to take your questions. Thank you.
Thank you so much. That was incredible. Yeah, I plan personally to be at Disney World 2045 because it happens to be my spouse and I, it'll be our 30-year anniversary. So
that's special.
We're gonna have that's
Yep.
Yeah. All right. So let's go ahead and we're gonna jump right into some questions. And we had quite a few. Let's see. With Habitable Worlds Observatory, with HabWorld, can the shade be moved relative to the scope or will it be fixed?
That's a fantastic question. I don't know that they have the answer yet. This observatory is in the design phases. So I think there's going to be some really hard thinking about the pros and cons of each of those kinds of situations. Because I think much like JWST and of course Hubble, we're not going to be able to send astronauts out to fix it. So they're going to have to think long and hard about the best way to do that, to maneuver the star shade.
Understandable, makes sense. All right, so regarding Psyche, how can an asteroid acclimate only one or two elements from the primordial dust? Accumulate, excuse me, accumulate
Yeah.
only.
Yeah, gravity. So much like the terrestrial planets have that iron nickel core and the gas giants do not, the temperature range of where different elements kind of crystallize out of the nebula. It's dictated by distance from the sun, so gravity, but also by temperature. So that's my top of the head answer to your question. I think one of the science investigations will be to answer that question as well and just learn a little bit more about how and why Psyche is the way it is.
So, and staying on in that same vein of asteroids, is there maybe an explanation for the square shape of Bennu or at least one other asteroid?
So that's a really good question. It turns out that Ryugu, which was where the Japanese did their asteroid sample return, also is kind of square like that. I don't know. I don't recall. I'm sure there's an answer for it. I think Google might be able to tell us the answer. I don't have that answer off the top of my head, but thank you for asking. I'm going to go look it up.
All right. And then another question, just again in that same kind of vein with regards to commercial companies. Do commercial space companies have to develop their technology from scratch, or do they borrow NASA technology? Are they given guidance from NASA? How would they go about that if we were to go down that road?
Yeah, all of the above. Yeah, NASA did the hard work, and others did the hard work. Uh, designing rockets, designing sample return capsules, designing the Jet Propulsion Lab was created because they were figuring out how to mix up the chemicals in order to have good rocket propulsion, right? So a lot of that work is published. A lot of that work is commercially available. So they do and can borrow heavily from the work NASA has already done. And they also get guidance from NASA, right? They might say, we want to be able to have this be limited to 100 kilograms. We want to have a refrigeration system. So when we collect samples from the permanently shadowed regions of the moon, we want to be able to keep those samples frozen. So we need to have cryogenics available that is within the weight limit so that we can actually launch the thing off the moon as well and keep everything cold. So there's definitely design elements that are required for the successful proposal to meet the science needs of the activity.
And then swinging over to Titan, how does Titan maintain its atmosphere against solar wind? Does Titan have a magnetosphere?
So the sun is pretty far away. And I mean, one of the things that's pretty basic that I teach my astronomy kids and my students is that in order to maintain an atmosphere, you have to have a source for the atmosphere. And you also have to have a body that's large enough that can hold on to those elements, right? Or hold on to those molecules. So part of the problem with Mars is that Mars no longer generates enough gases to maintain its atmosphere. And it's also small, so it doesn't have the gravity to hold on to its atmosphere. So we believe in the past, when Mars was geologically active, it had a more substantial atmosphere that allowed liquid water to exist at the surface. Mars cooled off, the geological activity died down, no longer had a source for the atmosphere. The solar wind stripped off that atmosphere, and now we know, and now we have Mars. So going out to Titan, and I'm thinking out loud here. Well, this is a good question. I like it. So going out to Titan. So one thing, it's much further away. So the solar wind would not be as strong. It also has an atmosphere of nitrogen, which is kind of a heavy molecule, relatively speaking. So the lighter elements have probably escaped Titan's gravitational pull, keeping that heavy element of nitrogen. I don't know that people have published or talked a lot about an internal source of gas that would keep that atmosphere full. I bet you Dragonfly will have answers to that. But that's a really great question. I'll have to think on it a little bit more. Thank you.
Of course. I am so, like, we spoke a little bit earlier before the webinar, and I am so excited for Dragonfly. It's just the idea of us just taking this, this flight on another world so far away from home that it's incredible. And then not to mention the chemical composition that we're going to study, and that's just it boggles the mind to think of, and also can't wait. So it's very exciting stuff. All right, so with that, we are again at the top of the hour. So I do want to thank you so much, Nicolle, for spending your time with us here at Night Sky Network. And for our Zoom attendees, a survey will be placed in the chat right now that you can go ahead and fill out. And we always appreciate your feedback, your comments, your questions. And you can find this webinar along with past webinars on the Night Sky Network YouTube channel. And of course, on Tuesday, May 28th, you can join us again, where we will hear from Dr. Patrick Bricey on the brief history of everything. And I do see Nicolle has some survey results. Let's go ahead and take a look.
It always goes long. I wanted to make sure I shared this with people. So 62% think we'll find life on Europa. That's fantastic. Lots of others. Enceladus is in there as well. That's wonderful. People from all over the country. I love that rainbow pie there. And favorite space topic looks like 33.3% said cosmology in the universe. I got a couple of write-ins for comets. And what else? Everything, constellations, nebula, all of it. So that was great. Thanks for playing that game with me, everyone. This is the first time I've done something like that. So thank you.
That's awesome. Thank you so much. I mean, I feel like cosmology is the study of everything. You could have said cosmology in the universe, but that's okay. So again, thank you so much for tuning in, everyone. That is all for this evening. We will see you next month, and keep looking up. Thank you once again. I'm going to go ahead and stop the stream, and thank you again for joining us. That was phenomenal.
I had a good time. I mean, this is a fun talk to give, and tried to touch on things that everybody would find interesting.
Absolutely.